Hi, we have the AP Physics 1 past paper 2022. We are discussing free response question section. In this section, we have the question number 1 which carry the 7 points. Two blocks are connected by the string that passes over the pulley as shown above. The block 1 is on a horizontal surface and attached to the spring at its unstretched length, that is spring constant, force constant is K naught. Frictional forces are negligible in a pulley axle and between the block of the surface. Block 2 is released from the rest, moved downward before momentarily stop coming to rest. Okay. The K naught is the spring constant of the spring, M1 is the mass of the block, M2 is the mass of block 2, delta Y is the distance that block 2 covered before coming to the rest. Okay. Now the first question, block 2 start from the rest, speed up, then it slow down, momentarily come to rest at the position below its initial position. In terms of only forces directly exerted on block 2, only. Okay, sir, only block 2 we have to discuss. Explain why block 2 initially speed up and why it slow down to momentarily stop. So there is a two answer here, two parts, why speed up, why slow down. There are two forces on acting on a block, that is the gravity of the weight, you can say M2G, and the tension that is directed upward. At very beginning, spring is unstretched, block 1 does not pull back much, therefore the tension is small as compared to the weight of the block 2. This means net force is greater, that's downward is the weight is greater than tension, so net force is downward. So block 2 accelerate downward, its speed increases. Then what happened? Block 2 moves down, block 1 moves right, stretching the spring. The spring pull back harder and harder as it stretch. The increase the tension in a string, eventually tension becomes the greater than force of gravity, or you can the weight of the block 2. This creates the net upward force which causes the block to deaccelerate, slow down until it stops. So that's the whole scenario is happening there. Drive the expression for the distance delta y that the block 2 travel before momentarily come to rest. Express your answer in K naught, M1, M2 physical constant. So I am using the law of conservation of mechanical energy since the blocks start from rest and end at rest. So there is no change in kinetic energy from initial and final. So that K is equal to 0. So we have only discussed potential energy. So when the block is moving down, there is a loss in gravitational potential energy of the block 2 and spring is tightening. So gain is spring potential energy. So both are, there is a loss should be equal to the gain. M2G delta Y should be equal to 1 by 2 K naught delta Y square. Delta Y can be adjusted from this one. Delta Y is equal to 2 move from here K naught divide. Delta Y is equal to 2 M2G divided by K naught. So that's the answer. Next one. Indicate whether the total mechanical energy of the black spring earth system changes as block to move downward. We have to answer change or doesn't change. Explain the reasoning. So answer is doesn't change because reasoning gravity and the force spring forces are conservative, mean the work done in a closed path should equal to 0. There is no net change. Tension or normal force don't network, they are perpendicular. Friction is negligible everywhere, so no energy is dissipated as a heat. So block earth system is a closed, so total mechanical energy remains constant. So there is no change. Next part of the question is consider the system that include the spring, earth, block, both block and the string, but not the surface. Initial state when the block is at rest just before start moving. Let's final state be the when the block first momentarily rest. Diagram A, this is the diagram A, at the left below is the bar chart that represents the energy in the scenario where there is a negligible friction between the block 1 and the surface. The shaded in the bar is the energy. A bar chart represents the potential energy of the spring and gravitational potential energy of the block earth system US UG respectively. The initial and final states, this is the initial, this is the final. You can see in initial state spring energy is 0 and potential energy is maximum, gravitational potential energy is maximum. After finally, when spring is fully stretched, the potential energy in the spring is maximum and gravitational potential energy is minimum. So this is the diagram A explaining all of this. So positive energy value are above the zero point 0 and negative energy value are below the negative. So upward is positive and from downward is negative. As a whole we can consider. Now the question is complete the diagram B. This is a diagram B which we have to complete for the scenario for which friction is non-negligible. Now friction have to consider the energy for the initial state are already provided. This is the initial state and the final state have to provide. So in the energy final state using the same scale model as the diagram A, shaded area should start at the solid line representing the 0 point line and representing any energy that is equal to the 0 with the distinct line on a 0 point line. Now, what's the answer? You problem asks the final state where it's momentarily stops. So final state energy Ug is usually defined as 0 at the lowest point. So you can see the gravitational potential energy is standing for 0. Spring potential energy is the shorter than as compared to diagram A because the friction stole some energy. Spring is not as such as in case scenario 1. A. The total height of the two bars added together equal to the mechanical energy left in a system which is less than the frictional case as 4 unit, because you can see there is a 4 unit bar in this case. Now there is a total, you can see there is a 3 unit bar. So that is less than the frictionless case. So that's the answer. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share it with your friends. Okay, take care.